You know that both OpenAI and Google DeepMind solved 5 out of 6 Math Olympiad problems, Math Olympiad 2025. But those were the specifically trained models that we don't have. But these two guys just use Gemini 2.5 Pro that we all have to solve 5 out of 6 problems. The reason this is interesting is this shows that we are underutilizing these models. These models can be a lot smarter if we use them well. So they show this code, they created multiple agents that solve, review, self-improve, and do that in circles while until they decide that the problem is solved. So I want to read this for the purpose of understanding more how we can apply AI, maybe in AI research or in business. Even though I'm not interested in business, maybe some of you who watch, you can maybe apply this in business. Because there are reasoning tasks in business as well. So this was the situation. Gemini 2.5 Pro was agent for everything, and it was just circling around within these around 5 agents. And I think this really proves that there is reasoning in AI because these are new tasks that are never seen before. So they are just invented. So there is no contamination like maybe in other benchmarks like IME and Math and something like that. So this is the pipeline that we can use for other things as well. Initial solution generation with the prompt, this prompt. So it says you need to generate a solution. If you don't know, do not guess, do not hallucinate. Do not create solutions that appear correct but have hidden flaws. And I think this is a good prompting because now Gemini will be aware of those kind of solutions and it will put attention to this rule, and then it will not do it. It will be less likely to do it. There are more strict rules. There is a lot of prompt engineering here that they've done, I can see. So they probably spent quite a bit of time on prompt engineering, and that's what we should do as well, probably. And this is prompt for verification agent. So it says you are rigorous mathematician verifying the proof, the answer, and then it gives a lot of examples. It needs to catch mistakes, and there is justification gap. For example, something is done but not rigorously justified or explained. And then output format. So it's very big amount of prompt engineering. So after step 1, the initial solution generation, step 2 is self-improvement. So the same guy that generates the solution. And then step 3 is verifying the solution with the prompt that I just showed and generating a bug report. Go to step 4 or step 6, see below for explanation. So this one will go to step 4 or step 6. So it can decide to accept or reject, but I think this will be done in the end. So, or it will decide. And most of the time it will decide to go to step 4, review of the bug report. So this is step 4 for the other agent, not this verifier. And so this agent will check if this bug report is good and then improve the bug report. And after this bug report is good, then this agent that was generating the answer, that's gonna correct and improve the solution based on the bug report. And after that, go to the verifier again. So we see here at least 3 agents. So this one that's answering, one that's verifying, and one that's reviewing the verified or bug report by this verifier. So Elon Musk said that they will create a new company. It's gonna be called Macro Hard, I think, and they will just simulate how users interact with websites, and they will have AI, Grok, code the websites. So there will be just this infinite loop where Grok is coding websites and Grok is checking if the website is good and using it like a user until the website is fully done automatically with AI. So that's something similar to this, although this reasoning is a lot simpler. So you can also run multiple instances of this system on the same problem that are independent from each other, that are searching for the solution. I wonder, something like this can be applied in AI research, but AI research would be way more complex because this is just a single problem. Even if it's Math Olympiad, it's still a simple single problem. And compared to cutting edge science that best scientists do, Math Olympiad problems are a lot easier. So automated AI research would be way harder than this. First, because it's not so defined. Second, it's because the reasoning necessary is a lot harder than this as well, I think. But there are some easier things to do in AI research as well. So maybe slowly we will see AI doing AI research. And I think maybe in 4 years, we will have equivalent of a good experienced scientist doing AI research. AI research. They say here that one big problem was the thinking budget. So the output token window is too low. So that's why they had to use multiple agents and multiple calls, and they cannot solve it in one call. So I guess if we just extend the context window of these LLMs and then let it think or reason for a lot longer, maybe that's how they become smarter. So this step 2 of self-improvement after the initial solution generation, this is just simply doubling the context window for this initial solution generation. And that's it. Because it's the same agent. And when I say context window, I mean amount of tokens it can generate. Because amount of tokens it can just get and take is a lot larger. It's like 1 million tokens. By generating, I think, only 32,000. So we need to generate 32,000 and then 32,000 more. They also instruct the model that generated solution to review the bug report, and because maybe some bugs are not actually bugs. So there is just a bunch of looping, reviewing, and talking between these agents. Another interesting thing that happens with multi-agent systems is that they allocate as much compute as necessary to solve the problem. So they can scale compute, use more compute, as they tell each other, okay, this problem is not solved, let's continue, let's fix these bugs. Or if the problem is simple, then they will solve it quickly and decide to stop. And this reminds me of what OpenAI is doing. They are just scaling kind of compute, as I believe. So the main advantage of OpenAI is scaling the compute. So the reasoning, O4, O5, they will mainly be just trained on more compute, as opposed to some crazy new algorithms. Although they could have a bit more advanced algorithms because they pay a lot of best researchers, but I don't think so. I think the main reason O5 will be better is because of more compute. So as we get higher benchmark scores on humanity's last exam and these other benchmarks, I think it's mainly because of just more compute. Although sometimes research advancements happen that make everything a lot faster. For example, the new muon optimizer, I think it cut compute and data necessary by 2. So now it's 2 times faster and easier to train a model, which is crazy. This is crazy advancement. And this is what the problems and answers by AI look like. And it's really interesting to see this. This is AI solving a problem that it would take me so long to understand and solve. And this is really amazing and feel the AGI moment. Although it's not yet AGI, I know, but this is crazy. So in the first few tries for some of the problems, they gave some general vague hints. But then, as I understand, later they solved them without any hints as well. So all of the 5 out of 6 solved questions are solved without any hints in the end. Fully solved without any hints. This is so crazy. This is so crazy. Look at this math. And imagine like in 4 years, it's gonna be able to do some crazy math. It will be so useful. Look at problem 5. If you want to read this, it's so interesting. It's so difficult. I think like I would need like days and days and days thinking about this problem. And this is also the problem 5. And this is the solution without hint. and it's solving like crazy. How do those people solve this in like 1-2 hours? I don't know. Like, no way. This is too difficult. Check out my other videos. This last video, Quen3 Reasoning GSPO, I spent like 10 hours making this, and it's really well explained how Quen trains its reasoning model, and you will understand everything. And there is a bunch of memes in there to make it funny. So I'm gonna leave the link below. Okay, see you next video.